Hello community, so great to see you. We have something brand new because Google decided to come up with a new learning algorithm for all of AI. So, welcome to my channel, Discover AI. We have a look at the latest AI research papers. Beautiful. Now, you know classical when we train our AI model, any AI model, we have a supervised fine-tuning and then we have a reinforcement learning by verifiable reward functions. And now Google said, hey, you know what? Let's have a look at this. Let's have a look what's not working, and then we build something better. Okay, let's do this. So the first one, supervised fine-tuning, also as imitation learning. So what we have is classical. We have a teacher LLM, a big one, and then a little student LLM, maybe a 3 billion or 8 billion free trainable parameter model. And imitation learning says it all. No? We have a supervised learning paradigm. So the teacher says, look, the solution for this little square here, for this little cube here in the knowledge manifold is here, or the knowledge domain is here, this one. So I show you how to construct this, and now student, you rebuild it. So the teacher gives you the complete solution and the student is just imitating here in a learning exercise this exact teacher solution, full stop. Now on the other side, reinforcement learning by verifiable reward function encounters another problem. And whenever we have here a pass at 1, pass at 4 rate, that is really near 0, for the real hard reasoning, for the stuff that is really complex, has a high complexity, then all the reward signals are too sparse for our reinforcement learning to be effective at all. This reinforcement learning collapses here at more complex queries. So Google said, okay, let's analyze this, let's understand where the limitations, and let's build something new. So in short, it means that the traditional supervised fine-tuning overfits everything, and reinforcement learning lack here significant reward feedback on more complex, more logical causal reasoning tasks. So let's find a new solution. And they call this new solution, you're not going to believe it here, this as is supervised reinforcement learning. SRL, Supervised Reinforcement Learning, the best of both worlds and some brand new ideas. Okay, this is the paper, Google Cloud AI Research, UCLA, Google Cloud here, almost Halloween, last of October 2025, Supervised Reinforcement Learning. Now I want to do something new in my channel, no, a little bit more exciting. Let's frame it in different ways and let's make it easy. So the first one is you go to your, I went here to Grok 4, I put in the PDF, I had about 10-15 minute discussion about a mathematical optimization, and then this is the output of Grok 4. And here you have everything. This is the complete run through like I discussed with Grok 4. You have everything, and if you are this kind of person who loves this clear, structured, linear sequence, this is it for you to understand exactly what's going on. You have everything here for 1, 2, 3, 4, 5, 6, 7, 8, and a check. Great. And then you say, hey, Grok 4 or whatever you like, Sonnet 4, convert this into code, and you are done. So this is, before code exists, this is here the logical reasoning with the mathematical formula that you encode then in Python, C++, whatever you go for. And then if you have read the paper and you have looked at Grok 4, so you say, okay, so if I understand this right, so we are back to a teacher-student imitation learning paradigm where we rely on a strong LLM, like a GPT-5, to do the decomposition of the complexity for now a stepwise learning process of a student model, like a tiny little GPT-5 mini. And instead of an AND value to reward signal that we have now in the classical reinforcement learning, we decompose now the teacher's solution complexity, the sequence answer by the teacher, into multiple stepwise sub-answers with a lower reward structure. And this is it, and therefore we have also reduced or decomposed the higher complexity into multiple lower complexity elements. Is this the right understanding of this new study? And Grok 4 comes back, yes, this is it. So we know it. Okay. Now let's try another framing. Maybe you are not that person that likes this abstract. So let's go here with a simple step-by-step where I explain it here on an easy example. The example is learn how to make a cup of tea. And all the British, welcome my British folks here. We have here a student AI and we have an expert AI teacher. And so what's happening in this new supervised reinforcement learning? Step 1 is easy. You ask here the teacher LLM, and it was here the one model in this particular study to show now a complete demonstration of this task. So how to make a cup of tea? And DeepSeek R1 comes back and says, okay, first boil some water, put a tea bag in a cup, pour the hot water in the cup, let it steep for a few minutes, and remove the tea bag, and enjoy your cup of tea. Second step, if it was not already broken down into individual actions, now do this. Now, what an accident, we already had everything down here in action step, so it is already what you know. So each step will now become a mini training example, and you might already smile and say, oh, I know what you're gonna do, absolutely. So we build now contextual training prompts. Context engineering here on the level of training prompts, where we take a high complexity sequence of reasoning steps, we decompose it, and we build step-by-step new training data. So for each step, since we have a supervised learning paradigm, we build now a new input-output pair. Input is the context, the original question on all previous steps. What a coincidence. And the target is, of course, here the next step as, let's say, decided here by the teacher LLM next action sequence. Give you an example. So, training example 1, how to make tea. Expected target, boil some water. Then, okay, how do I make tea? I have boiled some water. Now the next step is put a tea bag in the cup. Then if you have this, next step is, or the expected target, if you check against here, the teacher LLM, pour the hot water into the cup. And what you get now is something beautiful, because now you just ask the student LLM, hey, you have seen here everything that the teacher does, now attempt yourself the next step. So now the student comes and says, okay, if I have this, I have now to predict here the next action, and I do know the solution, because this is here the answer given by the expert LLM, by the teacher LLM. So let's see how close I am. It is that easy, I know. So then now the student AI will try to predict the next step given the same context. Now, but unlike the standard supervised learning that you know, in this new supervised reinforcement learning, we let the student also generate here the inner thought sequence before it outputs here the action. So let's say the context is, hey, I've boiled some water and put a tea bag in a cup. Now we have this thinking process of the student. I say, okay, next the tea bag needs to come into contact with the hot water so the flavor can infuse. So therefore the next step, the action step, is pour the hot water into the cup. This is now the sequence that is predicted by the student AI. You're not going to believe it. The next step is compute the stepwise reward function. Since we have a supervised reward learning, now we compare the student's action and the teacher correct action at the same level of action steps. So the teacher said, pour the hot water into the cup, and the student came up with the idea, put the hot water into the cup, and you guess what? This is exactly, since it's such an easy example, the reward is, if it's identical, 1. And if it's only partly similar, you just give it a reward, I don't know, 0.9, 0.8, whatever. So if you have pour water in the cup or pour hot water in the cup, it's not really identical, because I hope you have a hot water, but you see the reward function is now generated here simply by the similarity of the student's actions, that is, if you want now, designed, and the given teacher action, the correct action by the GPT-5 system. Now, interestingly, what I like is that you have here the inner thought here of the student LLM, but when computing the reward, at this first approach, Google decided not to integrate here the inner thought into the computation of the reward, but guess what? Yes, we know how to do it. So at the moment, only the final action is evaluated for the reward function. Then we have step 6, and you know, it is SRL, so now we come to the RL part. The supervision is done. So the student now updates its internal tensor weights so that it's more likely to produce here the high rewards, so the teacher-like actions in similar future context. It reduces here the probability of low reward actions, and the update keeps here the student distribution close here to the teacher's one. And how we do it in a classical RL way, GRPO with a Kullback-Leibler regularization part, just as PPO does here in the classical reinforcement learning from 2017. So you see, each mini step that we generated now by an AI generates now a dense reward signal. We do not rely here on the binary success failure reward signal, but on each step of every action that we have to take to prepare a cup of tea, we have now a reward signal right at every action for the full recipe. And then, and this is now interesting, then they say we decide to have a dynamic sampling as a quality control step at step number 7. They say, you know what, since we have here autoregressive system, so a purely statistical system, during the training the system runs several tries, several rollout for each steps. And the authors decided to go with 8 responses per context and measure how variable the rewards are. Now, it's easy, if all 8 are nearly identical, so there's no additional learning signal, that means the model is either always perfect or always completely wrong in the same way, the system now can say, okay, stop, skip further samples. Nice. And then step 8, you're not going to believe it, repeat everything for all step for thousands and thousands of examples across all the different tasks that you want to train your AI in your domain knowledge graph. This is it. Teacher answers gets broken into stepwise samples. Each sample trains here the student LLM with a stepwise reward function, and the student model gradually learns how to take correct action in complex multi-step tasks that are now here really the problem here for long argumentative exercises here. Now, of course, you see the dependence. No? If you have a teacher model that is not able to do this on this particular domain, let's say theoretical physics or chemistry or financial, whatever, all of this will not converge. What a beautiful study. So easy, so simple. I like it. This new foundation learning provides here more stability for structured reasoning because it evaluates simply every small move along the way, comparing here the experts, sub-action, not just the final results. And they show that this new supervised reinforcement learning works better than the normal reinforcement learnings for all the problems where the final success is rare. You always have a learning signal at every step, whatever is the higher complexity. Now, since I enjoy here another frame, let's have here another framing, how you can do this. Just imagine you are here in a cooking class. Yeah? So what is it? SRL can be summarized, I think, in this easy way. The teacher shows here the full recipe once to the class. On the whiteboard says, look, these are the steps, 1 to 10. Then the teacher breaks it into steps and asks, okay, what comes next after each step? And now the students explain the reasoning, why they think you should now add flour and eggs and whatever, and propose the next action. Maybe I should mix it now. The teacher now scores the action's closeness by the student to the real one that the teacher would do. And then the students slowly adjust their internal policy, reinforcement learning policy, based on that particular score, how close the student solution is to the professional solution by the teacher. And all of this is repeated until the student can perform the full recipe independently from any instruction given by the teacher, because now the student has absolutely learned how to do it. So you see, we have fused together the supervised part and the reinforcement learning part in this new approach. Now, what are the benchmarks? What are the numerical results? They have here different benchmark data and then the average here. Great. And they give us here the base model as a QN 2.57b instruct. And then what's really important is training here with reinforcement learning and training with supervised reinforcement learning. Now, I think it is not that easy because just have a look here at the first benchmark for the classical old-fashioned reinforcement learning. We have 52%, and with this new methodology, we only have 51.5%. So it's not always that it's better. No, sometimes it is better, like here in the next one, 47. It increases here to 50 with supervised reinforcement learning. But in general, you go here for a particular choice of benchmarks that were cleverly chosen by Google. So on average, you go from 24.5% to 27.6% performance. So the increase is is there. It is noticeable. Let's put it in this way. Yeah? It is notable. So yeah, just be aware. This is, let's call it a best case scenario if you do this. Now you might ask why. And at the end of the video, I will give you several ideas what steps to take to further improve this, because we want to get better than Google. Yeah? As I told you, there was this particular step of the filtering process, of the quality assurance. No? Now look, let's have a look here at the numerical data. Again, we have here the training with the reinforcement learning, and you see with the classical reinforcement learning, where verifiable feedback, we have 24.5%. Great. Now, if we do the new supervised reinforcement learning without the particular step of the filtering, so this quality step, the result would be of this new methodology, 24.7, which is compared to the classical SRL, 24.5. So we are 0.2 difference. So, okay, so I would argue if we do here the quality filtering, okay, we get a better result. But what would happen if we would do the same quality filtering here for the classical reinforcement learning? So you see, it gives us here a good interpretation. Where are we with the performance jump? Conclusion, these are the authors here, quotation mark. They say, by introducing now this supervised reinforcement learning, a real interesting form of a new learning paradigm, a new method designed to teach LLMs complex reasoning skills. This is it, complex reasoning skill. If you have simple things, go with the old one, but the more complex you get, and they tested this only on mathematical data sets, we have no idea how it works with open reasoning sets. We have to have expert demonstration training sets, and then we have a student that can learn this with supervised reinforcement learning. How we do it? We break it down, the expert solution that has a higher complexity, into smaller, manageable step for the smaller student LLM with less complexity. And then they say, we hope that this new methodology bridges here the gap between imitation learning, supervised fine-tuning, and reinforcement learning from verifiable feedback. Okay? And this would be the end. But if you are an expert and you are interested, hey, how can I improve this? How can I make the next step that Google did not publish yet? Now, I think there are so many hints that if you read the paper, please read the original arXiv paper, you will find that there are so many pointers into the future. So let's do this, especially since today at breakfast, I read this article here in The Atlantic, October 30th, 2025. Here's how the AI crash happens. The US is becoming an NVIDIA state. And I thought, this is an interesting paper. And they tell us here, you know what? 3/4 of the gains of the S&P 500 since the launch of ChatGPT came from AI-related stocks. 3/4. So I think we have to make sure that AI is a success story globally, and especially in the US, because we cannot afford that AI goes wrong or down the pipe. So how can we further improve this, that this growth is happening in the next years? And let's focus, how can we improve here this newly proposed supervised reinforcement learning from yesterday? So let's help here AI and Google in general. Now, what would you say? I would now argue that, if we have a difflip-like matching to computer reward that is proportional to the token or the substring matches between the model action and the expert actions, this is not really the best way to compare it, because this similarity is a syntactic proxy. But what I would be interested in is the next level, higher complexity, which would be a semantic proxy. No? I'm not really interested in the syntactic comparison. I'm interested, hey, is it on the same level? Does it have the same meaning? Does it have the same goal? So I would upgrade to a semantic measure, not a syntactic measure, as implemented in the Google paper. The second step I would improve your own Google solution here for a better AI is the expert traces are segmented into discrete steps. Now, this is kind of a problem because in mathematics it works nice, in theoretical physics it works nice, but in real-world traces, maybe those are more unstructured, that you cannot chop them up in clearly identifiable sub-pieces, You have overlapping, you have not clear step boundaries. So you will be much more in a noisy environment. And then there are ideas that assist the LLM is only cherry picking here the easier segments, but it drops here the complex part because simply it was not trained on this. So I think either we can now improve that we find algorithms for unstructured traces, that we find solutions, how to structure them in a new methodology. So if you are interested, hey, have a look at this. Maybe you have an idea how to code this. But in any way, I think this selection bias in the training data creates a bias and limits here these new methodologies to domains with a clear expert decomposition methodology, like in mathematics, like in theoretical physics, like in chemistry, like in medicine. So if you have any idea, I think you can really contribute here to the development of AI. The next thing that I thought, ignoring the internal monologue here. No, this is such a hint that Google gives us, no? We want that the LLM shows us the internal monologue, hopefully of an open source model, so we can then check here in the reward calculation risk that there's really a coherence between the internal thought sequence and the action that is chosen based on this thought sequence. So supervised reinforcement learning already allows in the code implementation for a free-form natural language in a monologue by the AI, but it does not integrate it in any way into the reward function. And I think this can be easily done. We have the code, we have the ideas, we have 2-3 methods I can imagine immediately. So let's implement this. Yeah, it increases here maybe the runtime a little bit. I think maybe this will improve the performance even further, so that a model may generate plausible sounding thoughts that do not support the action is something we can eliminate also then in a filter process. And then let's come here to everything that is concerned here with your PO or PPO style updates here, and especially the Kullback-Leibler penalties. We encountered here that those Kullback-Leibler scaling is really delicate. Let's put it in a friendly form, because if you do it wrong, the training becomes unstable and requires heavy hyperparameter tuning, which is not what you want to explore and invest your time and money in. So maybe for the pure optimization of the stability of the algorithm, another further, let's say, methodology jump from GRPO into something a little bit more intelligent. If you have an idea, if you think, hey, I want to contribute to AI, I think here this area is definitely waiting for you. So have a look. Maybe you have an idea to optimize on Kullback-Leibler divergence or any other mathematical form of divergence where you say, hey, I have found a new form of normalization that is cheaper and more effective to calculate here. This would be great. I hope you enjoyed it. Maybe you want to subscribe, become a member. Anyway, I hope I see you in my next video.